Hi everybody, welcome to another video of Roman Just Codes. I'm Roman, and in this episode of the Angular PWAs and Google Maps series, we'll be adding the feature of push notifications on an Angular PWA using Firebase Cloud Messaging. This feature is extremely important as it represents one of the cornerstones of what makes a progressive web app a PWA, since it leverages the power of service workers, a type of web worker, to accomplish this. Let's proceed. In our fictional package delivery PWA web app called UPS, we'll be adding push notifications to notify our users when their package has arrived or any other message we want to send them directly, regardless of whether they are in the web app or whether it's not even running. Please check the previous videos in this series to check all the features we've added already to this PWA, such as Google Maps, Directions API, Places API, Firebase Authentication, and more. In this video, we'll learn how to simulate pushing notifications from the server onto our apps. For now, we'll simulate using a useful feature of the Firebase console called Compose Notification. We'll focus on the front-end side of things and not on the back end. We may do that in a subsequent video. That's why we're using this tool. This tool allows you to provide a title and a body text for the push notification message and the device's FCM registration token to send the message to. This is a unique identifier generated by FCM to uniquely identify a device that will be receiving notifications directly from Firebase Cloud Messaging. Within the app, we'll receive the push notification in the form of a toast message that slides from the top of the screen. You can customize it any way you want, so long as you provide the right hooks to receive the information being sent to you from FCM. That's the beauty of implementing it via Angular and the Angular Fire package. When the user is not on that screen, or the application is not in focus, or the browser is closed, users will still be seeing it as a message that shows as a regular notification from your system, just as you receive any other notification. Bringing the application back into focus, the app continues receiving the push notifications from within. You can make it so it dismisses itself automatically after a few seconds, or manually dismissible via a close button. The sky's the limit as how you want to implement the notification approach. I'm using common patterns used, so you should consider sticking to that as well. And with that, let's get started. Firebase Cloud Messaging, or FCM for short, is a cross-platform cloud solution for messages and notifications for Android, iOS, and for web applications, which currently can be used at no cost. You can tap into this functionality via Firebase. We'll be dealing with a basic implementation, but you can further explore this topic via the links provided below. In the Firebase console, scroll to the bottom of the main dashboard screen where it mentions Cloud Messaging. Click on that section. Once in that page, click where it says Send Your First Message. This will redirect you to the Cloud Messaging Compose Notification tool. This allows you to simulate your backend sending messages to your devices using a push model. But for that, the device running your application will have to register in order to receive the notifications. At a minimum, for sending a notification, you need the notification title, the notification text, which represents the body of the message, an optional notification image and name. On the right-hand side, you see a preview of what the notification will look like when your device receives it. And when you're ready, you send a test message. You may notice there a long string of characters. That's the unique registration token that will receive our test push notification messages. This is key for successfully receiving the message, so keep that in mind. We'll talk about that more in a second. Let's get back to the project. By now, If you've been following along or just joined us, the UPS project repo from the previous videos has already the dependency required for this project to tap into Firebase Cloud Messaging from Angular. That's the Angular Fire module and the Firebase NPM package, so go ahead and install it if you haven't done so. Back in the code, in the app module TS, import the dependent packages. In our case, it will be the Angular Fire messaging module. Add it to the import section of the Angular apps main module. Let's create now the service worker that will bootstrap the connection to our Firebase Cloud Messaging instance in the cloud. Create a file called Firebase Messaging SW.js. This is the common file name used since Google already provides this file for you to add to your projects to make the configuration process easier. Visit this URL or search for Firebase Messaging SW.js, and you should be able to find this resource where they provide what the boilerplate content of this file should look like. Copy the contents of this file and paste it back into your project file. Inside the Firebase Initialize App method call, replace the contents of the Firebase configuration by the ones from your project, exactly the same ones you have on your environment.ts for doing the Firebase authentication and all things Firebase from Angular. It is imperative to have those pieces in place prior to proceeding, otherwise the communication to FCM will not be successful. Let's proceed now with the hooks for registering and listening for notifications. In the app component.ts, import the Angular Fire messaging service from the Angular Fire messaging module. In the constructor, inject a reference of this service so we can tap into this functionality. I'll add the ng-on-init lifecycle hook since I need it to initialize things here. I'll be needing two methods, one called request permission, which will handle the requesting of permission from the user to accept notifications from this app, and obtaining the unique token that will allow this specific device running the app to receive notifications, as well as a listen method, which, after establishing the connection, will listen for incoming notifications. Inside of the request permission method, I'll subscribe the request token observable from the Angular Fire messaging service. The request token does two things: request permission from the user and fetch the unique registration token if permission is granted. If successful, the observable notifies us back with a token, which you should hold on to or send it to your backend and associate it to this user, because this token is unique for this user for this device. The user can have multiple devices, so this is for this user to receive notifications on this device. That's the reason why you should store it somewhere to send notifications to this user's device. We'll use this token later in our simulation, you'll see. If the user declines, we can handle it in this error callback. Actually, let me go back and console it out so you can see what the token looks like. Cool. Another configuration piece that is required, since this is an Angular PWA, is add the Firebase messaging service worker we created earlier and add it to the angular.json configuration file and configure it as part of its assets. So this file also gets served with our web app. Okay, I'm done with that. Let's get back to the code and finish the rest. So, with the request permission method in place, I'll invoke it in my ng-on-init so we can start testing things. Open the Chrome DevTools console panel. Let me zoom in a little bit so you can see. There it is, our unique registration token that we will use later to send messages from Firebase to this device. You must always register first in order to get the token. You can implement your own logic to send it to your backend and associate it to this logged in user in any way, and Firebase provides examples on how to do just that. Notice I didn't get a pop-up from the browser asking me for permission to receive notifications. It's because I already accepted it for the sake of this tutorial. Let's finish the listen method. So first we register. Now we'll be listening to the messages observable and subscribe to it as well. It will yield a message, which represents the actual message payload received from FCM. Let's log it out so you see what it looks like. Let's call it right after the request permission method. Grab the token we receive upon requesting permission. And let's go back to Firebase console and the compose notification tool. With the title and body text in place, I send a test message. But first, I have to add the FCM registration token I'm using on my development device below. Add it and click test. Check the console. And there's our notification with our title and body inside a nested object called notification. By passing this token, we get this notification payload. Even at this point, you can start celebrating because the notification pipeline is already in place. From now on, it's mostly the icing on the cake and customizing how I'll be consuming this push notification within my app. Let's start creating some of the models that will hold the notification data. Create a folder called Models, and inside it, I'll create an interface called notificationModel.ts. This interface will only have two properties: body, type string, and title, also type string. The only two properties I'm concerned with at this point. Inside the services folder, let's create a service that will keep track and serve the notifications throughout the lifetime of our application. Let's cd into it. Let's use the Angular CLI to generate a service called notification. This service will hold a reference to the current notification being received. We'll make it a behavior subject of type notification model, so we can expose it as an observable and subscribe to it. Make it null by default. We need a way to set the notification. As well as a way to get it as an observable so other entities can subscribe to it. Let's save. Now let's create the component that will represent the toast message. You can use an existing toast message library if you want, but hey, you know me already. If I could make it in a more lightweight fashion and very encapsulated, I'll take a crack at it. In the components folder, I'll create a notification component using the CLI again. In the markup, I'll create a top-level container called UPS notification panel. I'll speed through the rest of the structure, but at least let me go over a little bit. We will show a notification logo, We have a container that holds the title and the body of the notification, and a way to dismiss the notification manually via a close button we create using a div. Let me add the CSS for this component, and as you can see, I'm using a CSS transition to move it in and out of view. I have the logo being referenced from the assets folder, the container for the content, the styles for the close button, and a special class I created to drive the transition by manipulating the top property of the top level container. In the component, add the encapsulation option of view encapsulation none. I'll add a Boolean flag called show panel. I'll create a property that will hold a reference to the received notification payload. I'll use a subscription this time, so I can dispose of the subscribed observable appropriately, but you should use the async keyword whenever possible. Inject the notification service via the constructor. I'll hold on to the subscription reference while listening to the incoming notification via calling the service's getNotification method, which returns an observable as you recall, and I'll grab that notification received and store it locally. As well as flipping the value of the show panel flag accordingly, whether the notification received is null or not. We'll use this show panel flag shortly. Let's not forget adding the method that will handle the dismissing of the notification panel manually by flipping the show panel flag to false, called dismiss notification. And as our duty to clean up after ourselves, implement the ng on destroy to properly unsubscribe from the captured subscription earlier. Let's save it all. I have to get the image that I'll use in the notification toast message called ups package.svg. Let's save, and since we've done a bunch of changes, I'll start fresh. Let's give it another shot at sending the push notification to our app. Good. Now this notification payload needs to propagate through our application to whoever is subscribed to the notification service listening to its arrival. Now, let's connect the dots. Back in the app component TS, upon receiving the incoming notification via Firebase Cloud Messaging through the listen method, we will push the notification into our system by feeding it into our custom notification service so interested components inside of the application can grab it and utilize it. Let's start by injecting the notification service. And inside the listen method, at the moment of notification arrival, push it into the notification service through the notification service dot set notification method. Populate the body and title, matching the notification model schema. And whoever is subscribed to that notification behavior subject will receive this notification. So, since we want the notification to show on top of all of the components, guess where I'll be placing it? Yup, the app component. And for the final stroke, Remember the show panel flag I mentioned earlier? Well, this is what it will do. Upon its value changing, it will trigger Angular's digest cycle to update the UI and add and remove the show notification panel class accordingly, which modifies the top CSS property of this container and triggers a CSS transition. So we subscribe, value is received, and if the notification is not null, show panel will be true, releasing the chain of events to make it slide from the top of the screen. The dismiss notification will flip it back to false, making it go right back up. Let's save all and take a look. Go back to the compose notification, send a test message, select the unique registration token, fire it up, boom, that's push notifications for you. Looking pretty good, but right now, unless I dismiss it manually, it won't go away. So let's add a cool improvement so it dismisses itself after a delay. Back to the notification component TypeScript code, I'll add a property to hold the reference to a timeout that I'll be adding shortly. Upon receiving the notification, I'll use a JavaScript setTimeout, inside which I'll flip the property to false after a 3-second delay. And in the ng-on-destroy, all I'll do is clear the timeout, as I should do just to avoid unexpected behavior. Again, receive the notification, show it, wait 3 seconds, then hide it. Save one last time. Send one last push notification from Firebase. Got it. Now wait for it. Done. You can play with the values being sent over. So just to prove that these values are real, let's just change them slightly. Let's change it again. This is exactly what push notifications are for, to let individual users or a group of users know about something important they need to know, but without being too intrusive. The push notifications, due to the strategic location in our application, should display virtually anywhere within our app. In the profile page, and on the map page as well. That way your users don't miss important information, which is the ultimate goal. And if the app is out of focus or not active, there, you still receive it. Getting back to the app, you still get them there without interruptions. I'm even closing it all together. And still I receive it. And that's it, folks. I hope you can leverage such an important feature as the Firebase Cloud Messaging is, and see how straightforward it is to integrate it in your Angular PWAs and web apps, and the value it adds to them. That's it for this video, so please stay tuned for more upcoming videos. Hit the subscribe button to stay updated, and please like this video if you found it useful. Thank you so much for watching.